Bismillahir Rahmanir Rahim. We are still in the cross, or in this topic, which is the cross or vector product, A cross B. We define how to find the cross product, we stated the properties, and then we spoke about the magnitude of cross product and parallel vectors. In this part, we are going to speak about the special products and the area of parallelogram and area of triangle, and also the volume of parallel pipe. The first point will be speak about the scalar triple product. Scalar triple product, that if we want to find A dot B cross C, well, that we are given three vectors A, B, and C, and we need to find A dot B cross C. This product is equal to, or A cross B dot C is given by determinant of A1, A2, A3, B1, B2, B, the determinant of the three vectors C1, C2, C3. This will give me the scalar triple product, and called scalar because the output will be scalar, it is not a vector. We know that for the dot product of two vectors will give me scalar value. So I have A dot B cross C or A cross B dot C. This is dot product of two vectors, and the output will be scalar value. The second type of the special product, second one, vector triple product. This will be, if we want to find A cross B cross C, this can be done by A dot C times B minus A dot B C. These are constant or scalar values. A dot C is scalar, A dot B is a scalar. This will be easier than finding the A or B cross C first, then A cross the output of B cross C. So no need to do the the vector or cross product 2 times for this one, because we have two ways. Either I will find A cross B, then I will find A cross the output of B cross C. This will take, well, this will take time to do it. But using this formula, A dot C times B minus A dot B times C will be easier and faster than the cross multiplication. So this is special product for vector triple product. And we say that vector, the output will be a vector. It is not scalar. Let's have example for this one and for these two. Given the vectors A 1, 2, 4, B 0, minus 4 and 5, C 6, minus 1 and minus 2. Let's find 1 A dot B cross C. A dot B cross C. Either I can do it by finding A or B cross C first, then we apply the dot product, or we can apply the special product. Formula that will be the determinant of these three vectors. So A dot B cross C is equal to A is 1, 2, 4. B is 0, minus 4, and 5. C is 6, minus 1, and minus 2. To find the determinant for 3 by 3 matrix, we can do it by the classical way. Just take 1 and cross the remaining. I can say this one for 1. I will multiply minus 4 with minus 2, minus 1 with minus 5, like this. Then go for 2, do the same thing, and for 4, and find. Or there's another way. I'm going to duplicate the first and the second column. 1, 0, and 6. 2, minus 4, and minus 1. The first and second one. Now we move diagonally. This 1, 2, 3. These are positive signs. So it will be plus, first one, 1 times minus 4 times minus 8 is plus 8. Plus 2 times 5 is 10 times 6 is 60. Third one, 4 times 0 times minus 1 is 0. So this is going or moving from left corner to the right corner, down. Now, for the negative sign, now move in this direction. This is negative, negative, and negative. So to be minus 6 times minus 4 is minus 24 times 4 is minus 96. Minus 1 times 5 times 1 is minus 5. Minus 0, because there is 0 there. Minus 2 times 0. This will give me the determinant of these three vectors. 1, 2, 4, 0, minus 4, 5, 6, minus 1, minus 2. Going from upper left corner to the right one down will take the positive signs. From left lower corner to the right up will give me negative signs. Now I can add these numbers. So I have 8 plus 6 is plus 68 plus 96. It will be 164. Okay, this will be 68 plus 96 plus 5. It is 169. So A dot B cross C will give me 169. And you can see it is scalar value. For the second one, B or 2, say, I need to find A cross B cross C. So either we need to find A cross C first, then find the cross product with A, or I can apply the formula, which is A dot C B minus A dot B C. This is equal to. Let me find A dot C first. A dot C is equal to 1, 2, 4 dot with 6 minus 1 minus 2. Give me 6 minus 2 minus 8 equal to minus 4. Is minus 4. Now, A dot B is 1, 2, 4 dot B is 0, minus 4 and 5. This will give me 0 minus 8 plus 20 equal to 12. So A cross B cross C is equal to this A dot C, which is minus 4. So it is minus 4 multiplied by B. And B is given by 0 minus 4, 5 minus A dot B equal to 12. So this is 12 multiplied by C. And C is given by 6 minus 1 and minus 2. So I have 0, 16 minus 20 minus, let me take it, plus, minus 12 with 6 is minus 72, plus 12 and plus 24. The final answer will be minus 72. 16 plus 12 is 28. Minus 20 plus 24 is equal to 4. So this is the vector of A cross B cross C. We just apply the special product. Now let's speak about the area of the parallelogram. A equal to, with the parallelogram we know that it is the base multiplied by the altitude. Which given by the product of two sides of the parallelogram. This is parallelogram. If this is B and this is A, two sides are created by the vectors A and B, then their cross product will give me the area of the parallelogram. It is A, or the magnitude of A cross B. And half of that one will give me the area of the triangle. So this is number 1. Number 2, the area of triangle is given by half of the cross product. We're speaking about the one triangle. This is triangle there. So the area of the triangle is equal to the base multiplied by the altitude, which is equal to 1/2 of the magnitude of the cross product A times, or A cross B. For the parallel pipe, third one, the volume of is given by the absolute value, the volume equal to absolute value of A dot B cross C. We have, say, parallel pipe, then the volume is given by the triple dot product. V equal to A dot B cross C, or the absolute value of A dot B cross C. That will give me the volume of the parallel pipe. Now, if the volume is equal to 0, if the volume, which is equal to A dot B cross C, is equal to 0, then A, B, and C are coplanar. Okay, let's say this will be the fourth one. For V equal to 0 if and only if A, B, and C are coplanar. Coplanar means the three vectors are in the same plane. If A dot B cross C equal to 0, the volume is equal to 0, means the height is equal to 0. It means A cross B or B cross C and A, they are in the same plane. So A, B, and C are in the same plane. In that case, the volume is equal to 0 and the three vectors are said to be coplanar. More example will be given in the coming part. So, but this is just briefly to speak about the volumes and area. Area of parallelogram is given by magnitude of A cross B. The area of triangle is half of the magnitude of A cross B. Then we can also find the volume of the parallel by the triple dot product. And if the volume is equal to 0, then we can say that the three vectors are coplanar or in the same plane. These are some applications of the cross product or vector product. And more example will be given later on.